People shut up. All right. So, a system of equations is a group of equations which share variables and possibly solutions. Possibly solutions. Either graphically or algebraically. So, the next three words you already know, or the next two terms, the next term you already know, and that should tell you the answer to the next two blanks. A linear equation is I missed the N there, an equation which follows a repeated and predictable pattern. For whom? You were here yesterday. So why do you need a booklet? Everyone who is in the room was here yesterday except these two. An equation which follows a repeated and predictable pattern to each variable. A linear system, therefore, then, is a group of linear equations. To solve a linear system means to find the value or values, because there might be more than one, of both variables that work in all the equations. Okay? That is the background to this. Now, I was going to explain this all before I started writing, but I did try thrice and nobody shut up, so I thought I would just start writing. Now, since everybody has shut up, I can finish what I was going to say. I'm going to go through this whole pack today because there is not one new concept in it. I'm also not going to specifically test you on it. It is not your fault we are out of time. I am, however, going to put a couple of these questions on the final exam that some of you may indeed be writing. Okay? Okay. There are three methods to doing this. One is graphing. We've just done a whole unit on graphing. It will take 2 seconds to show you how to do it. Elimination and substitution are totally algebraic. We have also spent the last graphing unit moving equations around algebraically, haven't we? So we've been practicing that too. That's what I mean by nothing new. So the first thing we are going to do is solve by graphing. Now, this tells you what that means. Find where the lines cross. Why is where the lines cross important? Because where they cross is an x and a y coordinate on both lines. And if that one point is on both lines, then that gives us an x and a y value that will work in two equations. Therefore, it is the solution to the system. Everybody cool? It's pretty easy when you think about it. So, remember, the easiest way to graph is to get into that form. M is the slope, but slope is also rise over run, and B is the y-intercept. That is where you start your graph. Then you identify the x and the y where the lines cross, and only where they cross, because that is the only spot in the whole universe where there is an x and y that works for both lines. Do you understand? Theoretically. Yeah? All right, let's move it along to your first attempt at doing so. There are two lines. We need to graph them to find out. Now, we know it's a system for two reasons. One, it's more than one equation. We know it's a linear system because we know those are both lines because there is no exponents, right? So we know that these two lines have the possibility of crossing somewhere, right? But we got to find out where that is. So let's graph them. Are either of them in a good form for graphing? In grade 10. If this was grade 9, we could just substitute and use tables of values, yeah? But we're going to do grade 10 style work. We're going to graph two lines. I'm going to graph a red line. I'm going to graph a blue line. The red line is y equals negative x plus 4. Is everybody okay with the algebra I have done there? I made y by itself by moving x to the other side. Once it hops over the equal sign, it changes sign. Yes? So I can graph that very easily, can't I? What is my y-intercept? 4. 1, 2, 3, 4. And my slope is negative 1. So that is down 1, right 1. And that line will go on forever. Yes? Everybody cool with that? I hope so, because we just did a unit on graphing. And we should all be pretty good at it. Yeah? Okay. What's the blue one going to look like? 2y is going to equal x plus 2. But I'm still not quite there. Y is going to equal 1/2 x plus 1. So I go up to 1, and 1/2 is up 1, right 2. Oh, look. The two lines meet right there. What is that coordinate? I'll let you draw your own. Sometimes it helps to zoom this in for you guys because you're looking up. That is what? 2, 2. That's an x, that's a y, correct? Does that work? Is 2 plus 2 4? Yes. Is negative 2 plus 4 positive 2? Yes. So that is the correct answer. Does everyone see how it works? It's pretty easy, right? How many times can a straight line cross another straight line? Once, and once only. So therefore, in this system, I can only have one solution. Everybody agree? Everybody cool? Okay. Now, just to warn you, don't take what I just said and think it means this. How many solutions are there to a system? One. Because Mr. Myers just said it can only have one solution. No. I said lines can only cross once, yes? Okay. The solution is anywhere a graphed line crosses another graphed line. Must graphed lines be straight? No. Next year you will be graphing things that look like this. A curve. And a line might go through it. How many solutions are there to that system? 2, because there's one there and there's one there. Everybody understand? You may graph this. How many solutions are there to that? 4. Cool? You may graph this. How many solutions are there to that? 3. Everybody picking up what I'm putting down? In grade 10, we only care about lines to show you the theory behind it. Cool? And since we're only using straight lines, they can only cross once. Good? All right. So you guys should be able to do the second one all by yourselves, yeah? Yeah? Okay. You guys go ahead. I'll go ahead up here. Red, blue. Is everybody good with graphing? You may not be done, but you understand the concept, yes? Everyone's cool? Okay, if you're not done graphing it, just keep working. Keep an ear on what I'm talking about right now. Can you envision any limitations to using graphing to solve real-life systems problems? Is there a limitation to it that you can envision? Because remember, this isn't real life. This is just math class, right? I'm just putting lines on a graph. Can any of you think of a reason why we wouldn't solve a problem using graphing? Tiffany? Pardon me? It's absolutely inaccurate, isn't it? What if this line went through right there? Do you have any idea what that value actually is? No. So graphing is not particularly accurate. All right? Now, why has it worked out perfectly here? Because I made the questions to show you the concept. Everybody cool? Now, you guys should have blank space at the bottom now, yes? Okay. I have another question that I do not wish to do with you. So I am going to pretend this is not here and go on to a regular sheet of paper and talk about what I want you guys to talk about, which is the next thing. Now, 1. Lines will cross when what happens? What would have to happen to the equations for the lines to cross? What must be different to make the lines cross? Pardon me? The solution? No, the solution's the only thing that has to be the same, right, Bronwyn? Because if the solution's the same, that's where they cross. But something has to happen. If I graph one equation, thunk, and there is a solution, the other equation must have something different than this one. What is it? It's got to have a reciprocal and a negative what? Slope. Slope has to change. Does everyone agree? Lines will cross when slopes are different. Now you went a little bit too far by saying they had to be negative or reciprocal, because that would make it perpendicular. But do they have to be? For example, if I graphed this, that line which is a positive slope, and then I graphed that line which also has a positive slope, do they have a solution? How many solutions can they have? 1. So lines will cross when slopes are different. What does that tell us? If slopes are different, you will have one solution. Everyone agree? All right. That should be what you are writing down in the blank at the bottom of your notes. The second thing you have to think about, what will happen with lines that are parallel? What's going to happen, Sam? They won't intersect, which means what? How many solutions do they have? None. Lines that are parallel have no solution. And parallel means their slopes are what? Are equal. And that looks like this. There's a line, right? With a slope of y over x, correct? Everyone agree? And here's a line with the slope of y over x. Same slope, yes? Will they cross? No. So you can either have one solution or no solutions. Everyone cool with that? Okay. Now, what if the following happens? What if, no, don't draw a Cartesian plane. Sorry, guys. X equals y. We could graph that, couldn't we? What would be 1 point on that graph? 1, 1, 1, right? Because if x is 1, y is 1. What would another point on that graph be? 2, 2, 3, 3, 4, 4, and so on, correct? Everyone agree? Is everyone okay with that? That's an equation, yes? Now, what if I gave you another equation that looked like this? 3x equals 3y. Is that a system of equations? Is it two equations? Do they share variables? Could we graph them? So it's a system, right? What would happen if we graphed them? Now draw it. xy is going to go right through the middle on a perfect 1, right? 1, 1, 2, 2, 3, 3, correct? That's the first line. What's this one? How would we graph this red one? When x is 1, what's y? 1. So it would be the same line, wouldn't it? How many times are those lines crossing? Infinitely. So how many solutions does that system have? Infinite. So the third option is when the lines equations look different, but are really the same. Then we have infinite. So it's 1, 0, or infinite solutions. Everybody good? No new concepts yet, yes? And we've done all this stuff already. Just giving it new names. Everybody cool? Okay. I'm going to go back to my actual notes now because I didn't need that. Okay, now, my good friend Tiffany, who is like, not his friend, just kidding, nothing. Tiffany got mad at me one day because I was talking and I was looking at her and she thought I meant her. I didn't. Anyways, Tiffany makes the valid point that graphing is not a good way to solve these, right? Because it's not accurate, right? So, of course, we need accurate ways to solve these if we are going to use them to solve real-world problems, right? Such as motion, time, money, right? If you're going to pay X amount of money over a certain amount of time for two different objects, eventually they're going to meet up, maybe. And where they meet up, that's an important number. So what we're going to do is discuss the two ways to solve these perfectly. And again, it's going to work out perfectly. There's not going to be any decimals or fractions. But the method will work even if there were decimals and fractions. Cool? All right. So here are the instructions. It's pretty easy. You can read those. It's no big deal. I'll let you read them for a second. But they don't really mean anything till you try it out, right? So have a quick read of that. And then let's actually make it happen. Everyone's had a good read? All right. Now, if I asked you for the answer to just that equation, just the blue one, what is stopping you from telling me the answer? You're the 30 smartest math students in the first semester in the whole school in grade 10. Why can't you tell me an answer here? Navneet. There's an X and a Y. We can only do algebra if we have one unknown. You can't do this, can you? Right? We're screwed, aren't we? So I'm just as screwed down here, aren't I? Because I have too many unknowns. Unless you do what I'm about to show you. This question right here. Isn't this the same as x equals 4y minus 1? Is everybody okay with what I just did here? When I move that over, now I have x equals 4y minus 1. I'm still screwed, aren't I? There's still two unknowns, yes? Right? I'm still in trouble until I look at the second equation. Because the second equation, what is right there? An x. What does x equal? 4y minus 1, doesn't it? So what can I do there? 3 what? 4y minus 1 plus 5y equals 31. Now how many unknowns do I have? 1. Can we solve that? Sure we can. That's 12y minus 3 plus 5y equals 31, correct? That is 17y minus 3 equals 31. That is 17y equals what? 34. And y equals what? 2. Everybody cool? Now I know one of my answers, don't I? Now, look at what's highlighted in yellow. 4y minus 1. Don't we know what y is? What is y? So what do I get to do there? X equals 4 times 2 minus 1. What is 4 times 2? Minus 1?
7.
So x equals 7. Does that give me coordinates on a graph?
Yes.
What are they? 7, 2. Easy peasy, right? Nothing new. Now, the question always comes up, why would you ever use this? There's a lot of reasons. For example, and I'm not incredibly proud of this, but you do what you have to do to get through university. I used to work at 7-Eleven. And you guys are well aware that 7-Elevens are not big stores, like grocery stores, yeah? They don't have a lot of storage space. So there was a very strict way to order stuff, so there was stuff on the shelves all the time. And it was done with systems like this. You had a graph of previous sales of a particular product for the past year, and you had a graph of your sales for the past month. And then you would have to graph them, and where they met would be how long your existing supplies would last. And if your existing supplies were going to run out before the next order date, you had to order some. But you had to use the graph to make sure you didn't order too much because there was no room to store it all. You understand? And everybody thinks working at 7-Eleven was easy. Now, of course, it's way easier now because now it's all on your iPhone. But in 1994, let me tell you, it was a big pain. Everybody good? Everybody good? Okay, you guys try the next one. Because you'll notice I'm only doing a couple of examples because it's always the same. So let's look at that. What one are we going to work with? Which equation? The blue one or the yellow one? You could choose either one, but I would choose the blue one. Why? Because y is already by itself, isn't it? Isn't this y equals 3 minus 2x? So what do I get to do with that? Where does that go? Down here, right? Because 4x plus 3y, but y isn't y anymore. What's y? 3 minus 2x equals 1. 4x plus 9 minus 6x equals 1. Yeah? Excellent. Negative 2x plus 9 equals 1. Negative 2x equals negative 8. X equals 4. What do I get to do with that? Y equals 3 minus 2, not x. What? 4. 3 minus 8, negative 5. What's my coordinates? Ooh. 4, negative 5. Gouda? Great. Everyone okay with it? Everyone feels they can do that one? Okay. Now listen, please. I showed you 3 methods on the first page, right? We've done graphing, we've done substitution. I've taught math for 17 years now. Every year I teach this unit. The first year I ever taught this, I taught substitution first, and then I taught the next method. And everybody got mad at me. Why don't you teach elimination first? It's way easier. So what did I do next year? Taught elimination first. Guess what those clowns said? Why don't you teach substitution first? It's way easier. So you guys are back on an odd year. I taught substitution first. After I teach you elimination, you guys can tell me which one was better. They're exactly the same. But you can tell me which one you liked better to see if you can keep that pattern going. Okay. This one's a little trickier. Okay? I'm going to graph this one first to show you what I'm... You know what? I'm not going to graph it. I'm going to trust you guys. This whole page can be summed up in one step, and I'm going to trust you guys. Yep. What happens when you multiply both sides of a linear equation? They get bigger. What happens to the graph? What happened to the graph here? It stayed the same, right? So, am I allowed to multiply both sides of a linear equation to change how it looks, but keep the same line? Yes. Multiplying both sides of a linear equation results in a new equation with the same properties. Does everyone agree? Everyone understand? All that stuff on top just proves that point. Do you all believe me? And we just showed you anyway, right? With the x equals y. 3x equals 3y. Everyone's cool, yeah? Okay. Now, look at these two equations. You're not going to do the graph. If you add those equations, what do you get? What is 4x plus 5x?
9x.
9x. What is 3 plus negative 3? 0. So what happens to it? Goes away. What is 0 plus 27? 27. What just happened? What happened to one of my unknowns? It went away. Isn't that the whole point? So now what does x equal? 3. So now I could fix this, couldn't I? Right? Because now I got x equals 3. So what can I put in either of those? 3. That's elimination. Which one did you think was easier?
The first one. The second one.
That's what I like to hear. I like to hear a bit of a mix because that means you recognize they're the same thing. I'm still substituting back here. Okay. The rest of this doesn't matter because you guys are smart enough to figure it out. Wow, I love teaching honors. None of the rest of that matters. Wow. I did not think this was going to go this well. All right. We're going to use elimination on this one. Why can't I solve this right now? Too many unknowns, correct?
Yes.
Okay. So let's try and get rid of them. What would happen if I added these equations? The 5s would disappear, wouldn't they?
Yeah.
And what would I get, Rachel? 7x equals what? 14, correct? And what would x be? 2. Now, what can I do with this x? Into which equation, Patricia? Do you think it matters? Of course not. It doesn't matter. Which one you want to use does not matter. So, I'm going to use the bottom one because there's no negatives. Right? So this bottom one becomes what? 4 times 2 plus 5y equals 23. 4 times 2 is 8 plus 5y equals 23. 5y equals 15. Y equals 3. What's my answer? 2, 3. Now, everybody right there says, elimination's way easier. There's one mistake. One thing you got to remember with elimination. We only worked with one equation, didn't we? What if we screwed up our algebra? You got to check. In substitution, you work with both equations, don't you? So at the end, you know you're right. But you don't know you're right here. So since we worked with the yellow equation, what do I need to do with this? I need to put it up here. What is 3 times 2? 6. Minus. What is 5 times 3?
15.
Is 6 minus 15 negative 9? So I'm correct. Everybody cool? Now, elimination or substitution? Who said both? Because there's times when one is better than the other. You're absolutely right, Tiffany. Right? Yeah. Can you paint a whole room with a paintbrush? Sure you can. What's better? The roller. Can you paint the border around your window with a roller? Not easily. You use the right tool for the right job.
You can get small rollers.
Shut up! Okay, now, stop. 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 Don't make me do that dick thing where I just start talking quietly and writing. Okay. Look at this. Is this one easy for elimination?
No.
No. Why, Sam?
Because they're not the same.
Nothing matches up. What am I allowed to do to change the way it looks? Multiply. So what if I multiply this side by 2? What would I get? 2x minus 4y would equal what? 14. Now, can I eliminate? I can, can't I? What do I get? 5x equals 15. What does x equal? 3. Now, where do I take that 3? Anywhere there's an x. 3 minus 2y equals 7. Negative 2y equals 4. Y equals negative 2. What's my solution? 3, negative 2. What do I have to do in elimination? I gotta check. I gotta check with the one I didn't use, right?
Yeah.
What's 3 times 3? 9. Plus, what's 4 times negative 2? Negative 8. Is 9 plus negative 8 1?
Yeah.
Yes, so are we right?
Yeah.
Yes. Look at the next one. What's wrong with it?
They're not matching.
Nothing matches. What am I allowed to do? Multiply. How many am I going to have to multiply? Both. What am I going to work with? X's or Y's? Does it matter? No. Why would you say Y's? Why did you guys choose Y's? Smaller number. What is the number that 3 and 2 work together with? 6. Oh, wait a minute. Isn't that lowest common multiple that we did a while ago? Holy crap. Unit 2 coming back to Unit 8? No. Math going full circle? Stop it. What am I multiplying this one by?
2.
What am I multiplying this one by? 3. What is my new equations? 4x minus 6y equals 40 and 33x plus 6y equals negative 3. Put them together. 37x equals 37. X equals 1. What do I do with that? Anywhere there's an x. 2 times 1 minus 3y equals 20. 2 minus 3y equals 20. Negative 3y equals 18. Y equals negative 6. What's my answer? 1, negative 6. What must I do? Check. What's 11 times 1? 11 plus 2 times negative 6. Negative 12. Is 11 plus negative 12 negative 1? Are we right? Brilliant! Where was this 30 of you for the previous 7.8 units? No offense.
Yeah.
Huh? Second last day of school. Bam! Might I ask how this is different from trig? It isn't. Tan 70 equals x over 13. Algebra. Oh.
Hey, at least we know math. What? Are you kidding me? I didn't understand that we did the unit and now I get What is this? Well, at least you now.
We know it now.
Okay.
Now, when it matters, obviously.
I love you guys. Okay. Guys, your notes should be done, yeah? Okay. I want to show you, and I don't want you to have to do it. I want you to actually pay attention. Okay? Ah! No, I don't want to do that one. Okay, guys, eyes up. have to do it. I don't want to. Alright. Everyone hates word problems.
Yeah.
Why?
Because it's a lot more information that we don't need.
But thank you. What is the only thing you need in math class? The numbers, right?
Yeah.
Read that question. Tell me what you don't know. You don't know the price of each item. So how many prices are there? 2. Do you know either of them? No. So what do you give them in math when you don't know? Letters. What letters do you use? Who cares? Right? Does it matter? P equals pop. C equals chocolate. Now, what do you know?
The price of more than one.
4 chocolates. How do I write that in math? 4C. And. How do you write and? Plus. 3P equals
5.3.
5.3. I thought you said there was too much information. What else do you know? 2 C's plus 1P You guys tell me you can't solve that?
I'm not going to tell you I can't solve that.
Of course you're not going to tell me you can't solve that, because you can solve that in your sleep. But there's so much information there, right? 2 numbers. Are we actually going to solve that? Of course not, because we know how to do it, right? Okay, that's why I didn't want you writing it down. Because as soon as I say write it down, you're all like, there's too much, I can't do it. And then when I say, what is it? Taylor goes right away, you don't know the prices. And I like how you had that you're an idiot tone in there. That was nice. I enjoyed that immensely. What are the things you don't know? The prices. Okay. Again, so much information in number 3. What are the 2 things you don't know?
Price or startup fee
You don't know the startup fee
and the monthly.
and the monthly fee. But what do you know?
1 month.
1 month. So 1M plus, how many startups would you pay? 1. 1S equals what? 260. 6 months. 6M plus 1 startup, because you only pay it when you start, equals 435. Could you solve that in your sleep? Of course you could. Right? What about number 4?
You don't know.
You need 2 investments, right?
Yeah.
There's investment 1 and investment 2. You got to give them variables, right? What are you going to give them? Why not? Let's just say X and Y. What do you know? How much money did the guy put in?
2,000.
So how much did he invest? So X plus Y is what?
2,000.
Wow. 8% of one of them. What's 8%? 0.08 of investment 1 and plus 0.1 of the investment Y gives them what interest? 190. Can you now solve that? Of course you can. How easy are word problems? Right. They were taken out of grade like 7 because they were deemed to be too difficult. I should get Taylor to go to Victoria and talk to the people that are in charge of math curriculum. Because she can talk to them the way she just talked to me, and then they'll be like, maybe we should leave them in because these kids are smart enough to do it. It's not a put down, you knew. All right, I'm going to go get your assignment. I'll be right back. Talk amongst yourselves. Oh, wait.
It's so funny.
Because I trust you, I'm stopping the recording.